Okay. Alright, so the first thing that we're going to do after we balance our equation is we're going to write question mark, and what is it that we're looking for?
The
moles of O2.
Water.
Oh no.
Moles of O2.
Of O2.
Right, we're looking for moles of O2.
This is chapter 6, isn't it?
Well, this is
No,
remember when I
we did in
said
chapter 6.
yeah, remember what whoa.
I just can't even.
Remember when I said that we were going to be combining skills that we learned from other chapters? Okay, so question mark moles of O2 equals, and what is it that we're starting with?
5.8
moles of water.
5.8 moles of H2O. Okay? Now, we need a conversion factor to go from moles of H2O to moles of O2. And the conversion factor that we're going to use, Zach, is what?
I don't know, Mrs. McKinley. Please tell me.
Okay. I'm glad that you asked. So,
I bit back my sarcastic remark just for you.
So what we're looking at is we're looking at these ratios right here. We have 2 to 2 to 1. Okay, even though it's an invisible one.
It's not a 1, that's a space.
It's an invisible one.
So 2, dot, 2, dot,
okay.
Colon.
Okay, so we want the moles of H2O to be on the bottom. So we have 2 moles H2O. And what do we want to be on the top, Lauren?
2, colon, 2, colon, 1. O2.
Well, that's the whole thing, but we just want to know water to oxygen.
1.
Right.
2 to 1.
1 mole of O2, okay, which comes from right here.
Wait, what?
Okay, because even though there's not a number there, we know that if there's no number in front of the O2, that means 1.
There's a mole on top of a mole.
I don't understand.
That'd be nasty.
So are we just multiplying by 1/2?
The book wrote it out, made it really clear.
No, it didn't.
Okay, everybody pay attention. This right here, 2 moles of H2O, comes from right here. Okay?
Yes.
Then this 1 mole of O2 comes from right here.
Yes.
Okay?
What about just H2? It's just left alone.
Yes.
It's excess.
We don't need, we're not asking about the H2 right now. They just asked us about the O2 and from the water. Okay?
So the fact that there's a mole on top of a mole doesn't matter?
No, remember before I told you that we were going to start doing equations at some point where we're going to have different substances in the equation?
No.
This is that point. Okay.
Let's say yes.
Okay, first of all, remember that I said that a chemical equation is like a recipe. It gives you the proportion of one thing to another.
But
So just
without
like
the tasty
if I was
outcome.
baking a chocolate cake and I knew I needed 4 cups of flour and a 1/4 cup of chocolate for my chocolate cake. If I want to bake 2 chocolate cakes, how much flour am I going to need? 8 cups, and how much chocolate am I going to need? A 1/4. Half, right? So this is the same thing, okay? You're using these as proportions. And what this is saying is, if I have 5.8 moles of water, how much oxygen am I going to get? Or equivalent for the cake would be, if the cake requires 4 cups of flour, and I have 16 cups of flour, how many cakes can I make?
Lots of cakes. Like 4.
4.
4. Wow,
Right.
that was bad.
I'm sorry, the smell is really bad.
Okay. So, going on. Alright, so the next thing is we're going to take 5.8 and divide it by 2, and what will we get?
2.9.
2.9
What?
moles
What?
of what?
Moles of O2.
Of O2, because the moles of water are going to cancel out. Okay? Alright, this is really not difficult. It's really pretty easy. So, alright, so does everybody understand that? You have it written down?
See, this was easy, but then when you give us homework, it's like,
So let's go on.
Einstein.
Let's go on to a new page. I'm going to write the next one down.
Hold on, get that. Wait, so we're done. There you go.
Okay, so we have C3H8 plus,
O2,
I think it's 502. 502
yield, H2O, and CO2. Right?
yields 3 CO2 and 4 H2O. Yields 3 CO2 plus 4 H2O. Okay, so now, first thing we're going to do is do what, right? Question mark. What are we looking for? Moles of oxygen. And that's 502, not 50. Okay, and remember when you're writing moles of oxygen, that's moles of O2, not just O.
Okay.
Wait, why O2? Because elemental oxygen is a diatomic molecule. Thank you. Okay. Question mark moles of O2 equals, and what are we starting with?
4.30 mole of propane.
4.30 moles of propane, which is C3H8 times. Now, you're going to have a conversion factor, so what are we going to use?
3
moles
no.
O2 over, okay.
502.
over 1 mole is propane.
Yeah, we're looking at this one right here, and this one right here, and we know if there's nothing in front of it, that it's a 1. Okay, so which one goes on the top?
502.
5 moles of O2, and what goes on the bottom? 1 mole C3H8. Okay. And now I'm going to do my canceling. So moles of C3H8 are going to cancel. Okay. And now I'm going to calculate. So hopefully you'll have your calculators with you.
21.5.
Yep. 21.50.
So we have 4.30 divided by 4.30 times
Probably between
5.
It would be 20. We're rounding this.
And we get 21.5. And how many significant figures should we have?
1.
No.
3.
3.
1.
These are exact numbers because they're like ratios. They're definition numbers, so you don't count them. The ones that come from this. Okay, so 21.5 moles of O2.
We did it, Miss Kimmy.
Okay? Good. Okay. So, and here's our equation. N2 plus 3H2 yields 2 NH3. Now remember, if your equation is not already balanced, you must do that first, okay? Alright. And then it says, calculate the number of moles of NH3 that can be made from 1.3 moles of H2. So we're starting with 1.3 moles of H2, and we're trying to figure out how much ammonia, okay, moles of ammonia. Okay, so what are we we gonna do first? Write down what?
Question mark, moles of
Ammonia, NH3 equals, and what are we starting with?
1.3 mole
Of H2. Okay, don't forget those diatomics because they'll mess you up at some point if you don't have the right thing. So don't forget which ones are diatomics. Okay, 1.3 moles of H2, and then what is going to go on the top of this equation?
moles of H2.
2, 3.
2 moles of NH3, and then what's going on the bottom, Lauren? The 3 moles of H2. Why is that going on the bottom?
Because on the other side, H2 is on top.
Right, exactly. Alright, so now I'm going to cancel my moles of H2. Alright. And I'm going to multiply then. We have 1.3 times 2 divided by 3 equals. And how many significant figures should I have?
It's 2.
2. So what will the answer be?
I don't know the calculator, so
Emily, do you have an answer?
2.6.
No. Did you divide by 3? Because there's a 3 on the bottom?
Can you multiply by 2 thirds? Is that right?
Yeah.
Okay.
Nick, what's the answer?
0.8 line over 6 moles.
Alright, and in this case, since we only want 2 significant figures, it's going to be 0.87 moles. Okay? Of NH3. Okay, does anybody have any questions?
are they going to get harder than this?
Yes, but not right now. Emily? 1.3 times 2 divided by 3.
We didn't do that.
No, we only, because we didn't have anything on the bottom besides 1. And we didn't cross out the 3, we only crossed out the units, Lillian. Okay?
But, never mind.
Okay?
I like your
Alright, so,
Oh, so